This is another integral that will be useful to know. Sine squared of x dx. We're going to integrate sine squared of x in general. We're going to derive the antiderivative, and we're going to compute the limits from 0 to pi over 2, and we're going to try different limits. For this integration, we need to know double angle identity for sine squared of x. So sine squared of x is 1/2 1 minus cosine of 2x. So whatever the argument, the angle here is doubled here. So we can substitute sine squared of x with 1/2 times 1 minus cosine of 2x. So we can pull 1/2 in front of the integral sign and 1 minus cosine of 2x dx. Now we can separate the integrals. So 1/2 times integral of 1 dx minus integral of cosine of 2x dx. We actually did these two integrals in problem number 1. Antiderivative of 1 with respect to x is x from lower limit a to upper limit b. And we did this, but I'm going to do it here very fast again. Let u be 2x and let du be 2 dx. So if u is 2x, then du is the derivative of 2x, which is 2 dx. And if you solve for dx, you get 1/2 du. Now we're going to place everything in terms of u. Now we know that antiderivative of cosine is sine. So sine of u, we can bring u back, which is 2x. And we have 1/2 here, and our lower boundary a to upper boundary b. So the only difference between this integral and integral on problem number 1 is the sign in between, which is plus or negative sign. So we derived the general antiderivative for sine squared of x. Now we can use any limits. In our problem, our limit was from 0 to pi over 2. So if we plug in pi over 2 as upper limit minus lower limit, we obtain pi over 2 from the first term. And if we plug in upper limit here, 2 times pi over 2 minus lower limit, 2 times 0. Sine of 0 is 0. Sine of pi is 0. On the unit circle, pi is here, and y-coordinate of this point is 0. So from this term we obtain 0. Again, we obtain 1/2 times pi over 2, which is pi over 4. So if we were computing the same integral, let's say from 0 to pi, then we were going to obtain this. Sine of 0 is 0. Sine of 2 pi is 0, because it's going to be one full rotation and coming here. So 0 and 2 pi are coterminal angles. So from this term we obtain just 0. So from here we obtain pi minus 0. Upper boundary is pi and lower boundary is 0. Pi minus 0 is pi, so 1/2 times pi is pi over 2. So the answer would be pi over 2 if the limits of the integral was from 0 to pi. So you can try different limits of integral using the same antiderivative we made here.